So welcome everybody to another episode of Steel and Whiskey. I'm your normal host here. I know we have some special hosts from time to time, but it's me back here again. And I have a special guest with me here today, Geoff Blumber with Hexagon. Geoff, you want to give us a little introduction, say hi to everybody, give us a little background on yourself?
Sure. As you mentioned, Geoff Blumber. I work for Hexagon as the 2D, 3D, and analysis technical manager for our solutions for the design of heavy industrial facilities, whether it's the steel and the piping, the steel and the structure, the steel and the pressure vessel. It's all designed and then engineered, and so I handle that. My background is I got an engineering degree from the University of Texas and got out of college as a young buck and did some time as an acoustical engineer. I worked as a structural engineer for a long time. I did construction management, went back to structural engineering after 9/11, and then in 2007 went into the software industry and have been there ever since, helping talk to people about how they do their design and engineering process and how they can leverage technology to do that, which suits me very well because I get to have the fun of helping people be more efficient, but I don't have to sit and run numbers all day, which is my sweet spot.
Perfect. Very good. Very good. So, one of the most important things about this podcast here is, of course, steel, but whiskey also, right? So, I see we can see if anybody's watching the video. It looks like you have a pretty good setup there for whiskey, huh? Why don't you tell us about that a little bit? Well,
So
you're obviously a whiskey buff here, I think, huh?
I am, and this is how my wife got me to move my office from a very visible room in our house to a quiet, out of the way room, was to bribe me with a whiskey room. So I have a nice room that I can sit and display my whiskeys and sit in a cozy chair and enjoy a whiskey now and then.
So who won out of that deal? Your wife or you? Like, who's the bigger winner there?
I gotta say that's a win-win situation for everybody because she's been known to sit in here with me in an evening or two and enjoy it. And most important, she doesn't have to look at the mess of my office. So actually, she might have come out ahead on that.
Very good. So I'm drinking a little whiskey here. I'm sure you've got something. So what I'm drinking is a Uncle Nearest. So show you the bottle here on video, kind of cool looking bottle. But Doug Evans, who a lot of people probably know, he had sent me a video, kind of a marketing video on Uncle Nearest not that long ago. So I went to the store. I was looking for Uncle Nearest, and I found they had a little sign about it. So I thought it was kind of interesting. I'm going to read to the audience what it says about this Uncle Nearest here on that sign. So apparently it's the most awarded American whiskey or bourbon of 2019, 2020, and 2021. Says it's the fastest growing American whiskey in U.S. history. More than 400 awards, including 48 best in class, and named Spirit Brand of the Year by Wine Enthusiast. Apparently, Nearest Green, affectionately nicknamed Uncle Nearest by his friends and family in Lynchburg, Tennessee, is the world's first known African-American master distiller. He is credited with helping perfect the globally recognized Lincoln County process, which is the defining distinction between Kentucky bourbon from Tennessee whiskey. Unique filtering of whiskey through sugar maple charcoal was named after the county where Nearest lived and made his highly regarded whiskey. So thought it was pretty interesting. So
that is.
What do you have to drink there?
So actually I've got a whiskey with a story as well. This is Restoration Rye from the Castle and Key Distillery. And its claim to fame is it was the very first destination distillery in the United States. And it was originally founded by Colonel E.H. Taylor after he had left Old Fired Copper, which many of you now know today as Buffalo Trace. So they've done a restoration on the facility that had sat abandoned for years, and it's certainly a beautiful place to go. They host weddings and events, and if you go tour the Bourbon Trail, that's certainly a place to stop and enjoy an afternoon.
Okay, very cool. I feel kind of bad because I had to read my story off of a picture on my phone, and you just kind of knew it and remembered it. So
it's only because I spent a day there.
And this is really good too. That was my first sip of it. It's excellent stuff. So tell us a little bit more about so you've been doing the software stuff, kind of technology stuff since 2007, you said. Is that correct?
Yeah.
So I'm sure you've probably seen a lot. Things have changed a lot over the years. What do you see? What's changed? I guess, what did things look like in the kind of technology landscape, software landscape, in the heavy industrial sector? What did that kind of look like back in 2007 when you started?
Yeah, well, in 2007, there were different discussions being had at that time. There were questions about, starting to do things in 3D for structural engineers to actually build models to do analysis in a CAD type environment. We were just in the AEC community, still doing a lot of stuff with 2D flat files for design and coordination, and 3D was just starting to take shape. But interestingly enough, in heavy industrial, they were already well into what most people today would call BIM. They were doing PIM, plant information modeling, because of the complexity of like an oil and gas offshore platform, coordinating the steel and the piping and the equipment to all fit in a very small space. And so it was interesting to see those two sides of the industry be at very different spots. And then if you're talking about steel construction, shipbuilding is another place that's, a lot of steel. And their process is almost like manufacturing at this point, right? So they're even further ahead of the curve than the oil and gas and process folks, who are ahead of the AEC folks as far as leveraging technology and doing 3D coordination. But over the years, it's been very interesting to see how data interoperability has helped streamline the process. I remember when Luke Nielsen was talking about Steel XML, being the new thing. We were hoping to get fabricators to, send in orders to the service centers on a computer instead of a fax.
Yep.
And to see where we've come now to 2023 has just been amazing to see the growth of technology, the adaptation of it, and how it's made really for better business and better buildings, better structures.
Mm-hmm. So you kind of mentioned a little bit there in talking that you kind of said, made the comparison about where the heavy industrial market was in 2007 versus kind of the AEC commercial type steel construction. So why was the heavy industrial ahead of them? I think you said they were a little bit ahead in the BIM world, right? So what's kind of some of the differences in heavy industrial design versus AEC? Why was heavy industrial ahead of the curve there, I guess?
I think mostly out of necessity, that when you look at a heavy industrial facility, there are some commodity parts. Maybe a pump would be a commodity part, an electrical panel perhaps. Whereas in the AEC industry, many things are commodities, right? There's a door, there's sheetrock. The steel frame between the two, though, is identical. The only difference is it wrapped in fireproofing and left outside, or is it wrapped with building materials?
Sure.
And so I think the plant industry had picked it up by necessity, because most of the items in those heavy industrial facilities are fabricated. The pipe spools are fabricated. It's not something that they're going and buying, pipe and bending or threading on site. This is stuff that is fabbed up in a shop and then brought to the field and welded or bolted together in sections. And then the coordination aspect of it, right, was really, I think, one of the other main drivers is going, we've got to fit a bunch of stuff in a very small space. And how do you do that effectively and efficiently? It's through a well coordinated 3D model.
Mm-hmm. And so just for our audience and for myself here to make sure everybody's on the same page and understands what we're talking about, when we're saying heavy industrial, what are we talking? I mean, we're talking like gas facilities and refineries, heavy pipe racks, things like that, right?
Really, yes. Any place that puts Goop A and Goop B into a process and spits Goop C out at the end. And it doesn't matter if it's food and beverage or pharmaceuticals or chemicals, of course, oil and gas being a big market segment there, but also the power industry, right? Taking coal or nuclear rods or LNG and turning it into electricity. Any of those types of facilities that need a structure designed and built to support the equipment that at the end of the day makes the special sauce that they run their business off of.
Right. Okay. So, and in those designs, and when we're talking about those structures, the moneymaker is what goes through the pipes, right? So we're pumping stuff through the pipes. The important thing that's going to make the owner money at the end of the day, which is the reason why we're building a building, is what's going through that pipe to get to the end and spit out Goop C, as you called it, right? I like those terms. Goop A, Goop B, and Goop C comes out. So, so Goop C has to come out the end, right? And that's what makes us the owner, their money. So then that makes me wonder about the whole workflow of the design process a little bit, right? What's the workflow for not just design, I guess, in this case? What's the workflow from, and specifically when we're talking about the steel structures, what's the workflow from design to detailing to fabrication of the structure part of those buildings?
Yeah, it's much like any other project, it's very iterative. And in heavy industry, we refer to two different types of projects, either a greenfield project or a brownfield project. Greenfield project's pretty simple. There's a greenfield and we're going to put something brand new there. And that design process is, they do a feasibility study, the front end design. And once they say, hey, this is something that's going to generate a return on the investment of building this, they start right away with the detailed design. And quite often they'll want to leverage stuff that maybe was already done in the feed side from the conceptual standpoint. And then that process goes on, right? It does become iterative where they fine tune and get the 3D design done. That information is shared to the structural engineers who will do their analysis and make sure that the structure is safe. Sometimes these structures are done modularly, where they're built in a fabrication facility and then transported across land, put on a ship, transported across land, and then set, at their final destination. And those are incredibly complex because they have to be detailed, built, and designed for multiple conditions, or they're built in place like your traditional type of project. The challenge on the steel side in heavy industrial, of course, is the space allocation. So things like gusset plates, large connections, large foundations that might interfere with piping. All of those things have to be taken into account early on in the process of doing the design to make sure that they've got a complete, safe, and well-coordinated project there at the end. We also have a lot of brownfield projects where they're going, this process facility is 40, 50 years old, and we need to go add some more stuff in. And in those cases, you may have 2D drawings of the facility. You may have to go out and do a survey. Now we're seeing more and more people using point clouds to take a survey of an existing facility and using technology to determine, hey, what piece of steel is that that's 50 feet in the air? Because it's a lot easier to determine it from the office with technology than it is to get up in a forklift with a tape measure. A lot safer too.
Yep. Safety's always a big deal, always a big factor. So yeah, so this is interesting, and from my standpoint, I'm always talking to steel detailers, steel fabricators for SDS2. Obviously, that's our core market. Those are our guys. So one of the big complaints they typically have with all of this is, steel is always the first thing that has to show up on site, but they're the last ones to get information. And to me, that seems backwards, right? Like, I got to be the first one on site. I should be the first one with information to get going on this and working on it in order to give myself, enough time, I'll say, to get this stuff done. So why is it that the steel guys, the steel detailers specifically, and fabricators, why are they like the last ones with the information when they got to be first on site? Can you tell me about that a little bit? Why that is?
So, well, the first thing I should say is they should not feel alone. That's something that when I first got into structural engineering, my boss said something to me that really helped me understand that situation better. In all projects, right, is that design typically happens inside out, right? They design, hey, what's the function I need? What's the form? And then from out there, what does this thing look like? And then when a project is designed, it is designed top down. What are the loads, on the structure? What's the equipment? What's, what kind of rooftop units? What kind of floor? What's the use? And so they design from the top down. But when you start construction, where do you start? In the dirt and go up. So while the steel guys are certainly, near the last, I would almost say that the concrete contractors are right in that same boat. And it is a challenge because quite often the structure being designed and detailed and fabricated, we're fast tracking projects so much now that quite often, a detailer may be detailing something and the engineer gets information that a piece of equipment, wasn't 4,000 pounds, it's actually 18,000 pounds. And geez, the structure's got to accommodate that. And we all know there's some safety factors built in, but not like that.
I think another important point about all that is to remember why that structure is being built and what's going to make money at the end of the day, right? And that's the goop. That's the goop, right? That's the goop that we're getting out of it. So when they're designing, they design the piping that transfers the goop, right? Yep. So they design the piping that's going to transfer the goop to spit out, we'll just say spit out money at the end, because that's really what it is. And then they say, oh, we got to support all this stuff. And now we're going to figure out how to build the structure around it to hold this thing up. And then they engineer it. They coordinate to make sure there's no problems, no clashing with the piping. And of course, I talk about it like it's a linear one-time deal. We all know that it's not, right? It's always this back and forth. But the point is, piping is the important thing. That's designed first, then the structure. And then once the structure gets designed, then they can finally pass it on to the steel detailer in order to do that, right? So, I always tend to think about, well, why are things the way they are, and can they be better, and all that stuff. In this case, it's hard to say, yeah, we can make that better, because we're not designing the steel structure so that we can do piping. We're designing the piping to make money, and the steel structure is kind of just a necessity, if you will, to support that stuff. So I always like to understand the whys and understanding how the process works and why the process works that way. And then I go, oh, okay, that makes sense that we're the last ones to get the information, but we got to be the first ones on site because obviously we can't put the piping up everywhere unless the structure's built. Right? That's not going to work. There's nothing to support it. So when you start to think about it that way in the workflow, it all kind of makes a bit more sense, right?
Absolutely.
Yeah. So we talked a little bit about technology, like when you've started working. How has that evolved? So obviously we talked about BIM was kind of a new thing when you started in the software stuff. How has that evolved today? And what technologies do we have today and are you seeing today in this side of the industry that weren't there? What was it, 15, 16 years ago now? Yeah. How's that evolved? What's it look like today? You mentioned point clouds earlier, so obviously there's that, but yeah, speak a little bit more to that.
Well, there is a lot of things that have happened really, and I'd say over the last 7 years that have evolved, right? When in the old days when people did things on, vellum by hand, there was a lot of coordination, a lot of time was spent, a lot of erasers used, and communication was slow and tedious. We went to doing 3D models of things because by nature, the 3D model is better coordinated. And so some of those 3D things that are sometimes hard to catch in a 2D environment became of great value. And then my 2D deliverables for construction become just an extraction from that 3D model. And that's kind of been the discussion that was going on about the time I got into software in 2007. And what has evolved from that is, hey, we're making all these 3D models that are basically a duplication of what's being built, and then they get thrown away. So what's the value, beyond what other value can be derived from that?
Yep.
And that is really where the industry is headed, which is for the owner to say, I have this concept of a digital twin. So I have my building, my skyscraper, my refinery, my power plant, whatever my thing is. I make money by that being up and running and being efficient, right? Whether it's the goop coming out of the pipe or a tenant in a building and being happy with, the fact that the HVAC system works.
Yep.
And so the value of having that digital twin as a model of your facility so that you have the information and know, oh, geez, that pump went down or that HVAC exchanger went down. Well, in the old days, it was, pull out some drawings, send a guy out to the field, let's figure out what's there, and then we'll go from there. Well, now if you've got a digital twin, it's as simple as booting up your computer and saying, oh, that piece of steel there up in the ceiling that you want to use to lift some heavy thing into your building, I know exactly what that piece of steel is because I've got a digital twin of it, and I can get that information very quickly.
So with BIM, let me see if I can articulate what I'm going to try to ask you and explain. Sometimes the thoughts in my head run faster than my mouth can keep up. I know it's hard to believe, but yeah, it's true. So with BIM, there's always been this question about legality and who's liable and all these things, right? So that's always kind of a point of contention with sharing models, right? So a lot of times engineers don't want to share their models with detailers for liability reasons because they're going to say, well, I just built this and it's just designed this way, but I don't want to be liable for you saying you use this information to detail or to fabricate that stuff, right? So there's still very much a PDFs, paper drawings, and communicating that way is still very much alive, right? And so then that makes me think about the digital twin and the legalities of a digital twin how does that play into the whole process and the workflow, and are owners and engineers and detailers and is everybody, on board with just accepting this digital twin? How is that going to impact things from the legality standpoint? And if does the owner own that model? Does the detailer who created the model own it? Does the engineer who created the model own it? Like who owns that stuff? Maybe you don't have answers. I don't know. These are just thoughts running through your head right now.
Yeah, and the answer to that is yes to all of the above. It is so widely varying. And you see, extremes on both sides. Where the median is, seems to be shifting towards more of a sharing, but it's so situational. And as a great example, I can say in the heavy industrial side, an owner will say, hey, as part of the deliverables for this contract, I expect a digital twin. And it's going to be in this format, from this particular software vendor, or in this neutral format. In addition to those old drawings that you gave me and the paper documents, I also want this. Right. And you see, and here's the interesting thing, it varies by country even.
Oh, yeah.
We got
probably not just country, probably by county in some parts of the world. I'm not gonna specify where, but I think we can all figure that out.
Yeah, I can say if you get south of Texas, there's a lot of places that say, I'm the owner, you're going to use my software in my environment, and that IP is mine, the model is mine, and that's the way you work, and it's going to update my system, and then there's no negotiation on that, right? Because the owner is owned by the state, and they just mandate, and that's how things are done. You also see that to some extent with the very few major EPCs are left. The companies that go, we do the engineering, we also do all the procurement, we construct it, we do turnkey, right? ExxonMobil wants a new refinery. Somebody like a KBR or a Jacobs or a Bechtel will come in and say, great, you tell us what you want, here's the keys, there you go. In there, where you look at it like an EPC, there's no worry about risk because it's all in-house, right? But there are those contractual splits where, geez, maybe I'm an engineer working for an architect and I'm working with a detailer and a fabricator, that maybe those two are the same or maybe they're not. And where does that risk shift if I am sharing, I got a Revit model from the architect, and now I'm using my tool to do the analysis, and I'm spitting out a 3D model that I then pass to the detailer, who then details it out and then gives, deliverables of, drawings or CNC output to the fabricator. Where does that risk roll back to? And that is probably the biggest problem in the industry now. We have the technology to do all this. It's
absolutely
very easy. It's the business processes that are still a little behind and haven't quite figured out how to handle that yet.
Yeah, I absolutely agree with all of that, and I see the same thing. It's technology's there. We can do it, but what's the business side of it, the legal side of it, and all of that definitely comes into play for sure. So yeah. Well, are you from? Hang on. I'm gonna just I feel like that was a really heavy, deep conversation. So I'm gonna stop for a second, reel it back. Are you from? You went to Texas, the University of Texas. You live outside of Houston. Do you live outside of Houston now?
I live just west of Houston, basically.
Are you just like a lifer, Texas lifer?
No, I was born and raised in West Michigan, and left when I was 18. So. I came down, I spent a little bit of time at Fort Knox, Kentucky, and then spent some time at Fort Hood, Texas, where I came to grow to love the Texas environment and the people and the food, especially the food, and have pretty much been here ever since.
Okay. So, well, I suppose you don't get those cold winters down there either, huh?
Oh no, when we get a little bit of snow down here, people panic. And
Yeah.
as a kid who, at 16 took driver's ed in 3 feet of snow,
Yep.
I laugh about it. You know,
That's I still laugh about it because it's Nebraska, middle of the country. We don't typically get 3 feet of snow. It's not uncommon for us to get, 6 inches to a foot or anywhere in between, right? So yeah, when I see Houston or any part of whether it's South Carolina, anywhere, say, well, they got a quarter inch or a half inch of snow and schools are shut down for a week. It's like, what? Really? Come on, what are we doing here? So, however, they're not equipped to deal with that type of stuff. So we have all the snow plows and the salt and everything to clear the roads here. So I get it, but
and here in Houston, we have very good AC systems and pools because it's been 100 degrees every day for 3 days already.
Yep, no, that makes sense. And well, we've been going through a little bit of a heat wave here ourselves. So getting towards the end of June, it's been what 90, but it hit 95 the other day here, I believe. So yeah, we've been getting that pretty hot stuff too. But I don't know, off topic here a little bit. I feel like we needed a little lighter conversation for a bit there after the heavy legal stuff and all that. So yeah, this is all good stuff. And we talked about the coordination side of, if we're gonna go back into some of the technology and how this stuff is done and BIM and all that. Going back to the technology side and having the technology side, SDS2 and Hexagon worked over the last few years to develop a good relationship. You guys are really good at the piping stuff, right? Great at the piping stuff. You've got the analysis stuff for the structural side of it, to design those members, analyze the structure, all that good stuff. We have the detailing side of it, right? We've got the connection design. So not everybody probably knows it, but just were you involved in any of that integration talk? And you mentioned the gussets. So one of the big things in SDS2 is the connection design and the gussets. So we've got that in your S3D product, so that we can find those clashes and stuff early on. Have you had much experience with that and companies using that technology?
Oh, absolutely. And that's kind of the rule of give an inch and ask for a mile.
Yeah.
Yeah,
you
I'm
guys
well
aware of that.
did a great job of putting your connection designer into our S3D tool, which is the integrated environment for doing process facility design. And it is fantastic because that is, like you mentioned, if there's a beam to column connection and it's within the flange depth, process facilities are like, yeah, that's fine. We like that space is pretty safe. But when you've got a big 3 foot by 3 foot gusset plate out on an X brace somewhere, well, gee, that could interfere with some piping or with a piece of equipment or a head clearance or an electrical clearance. And that's a real problem. And the problem is, much like steel's first on site, but last to get the information, connection design is usually left right up to the very end.
Yep.
And, if the project's been going along and they think that's 18 inches by 18 inches and you come back and say it's 26 by 34, all of a sudden you've got a major problem. And for a designer who is not a structural engineer to be able to just click in the software and go, hey, SDS2, you guys got some pretty good rules on, checking bolt clearance and tool clearance and sizing plates like that. So they don't have to be an engineer, right? The intelligence of the member size and the member lengths are all in the S3D environment, and your connection designer will read that information and put what I'm going to say is a very good engineered answer up there. Now, a structural engineer can go in and always tweak it later after the fact.
Sure.
But man, if, miss by an inch, miss by a mile. But if you collide, it doesn't matter if it's 6 millimeters, So it's of great value to those folks. And the other side of that, to streamline the detailer's job is if they can get from the design engineering firm that S3D model, correct me if I'm wrong, but I believe from S3D now we can export directly the SDS2 native plan or native file format so that the detailer can start with a 80% their model and not have to remodel from scratch or off of a piece of paper.
Right. Yep. And yeah, I've talked to so one of the big complaints. So you're right about all of that. Before I get into the complaints, that sounds terrible. But you're right about all that. It's outstanding. It's great to be able to see that along with the piping and be able to find that stuff early on in the design phase is outstanding. It's invaluable, right? But then, transferring that to SDS2, we get all of our main structural transferred over. That's great. The big hurdles as detailers that we run into with that is just that sometimes the designers don't have to be quite as accurate as a detailer does, right? So detailers got to be dead nuts. It's got to be spot on because that's how it's going to be fabricated. That's how it gets built. Designers have a little bit of leeway with, well, this is like the theoretical, analytical position of it, right? So there is still some challenges to overcome on the detailing side once we receive that model. But yeah, I mean, for the most part, that information is there and the intent is there to be reused again. So, and of course, we talked about all the legality problems and all that good stuff earlier too that everybody's got to consider. So not it's not just always a click of a button. We like to think it is, but yeah.
Well, and that's actually talking about sharing information. That is something that it has been a story I've seen and told over and over the years.
Mhm.
You also have to ask where did that information come from? Because much to your point, if the column distance is 18 feet 9 3/4 inches, that's very precise
Mhm.
for the detailer because that's what has to be fabricated.
Yep.
And ideally, the modeler should build that at center to center of 18 feet 9 3/4 inches.
Mhm.
A structural engineer who is building his own model and not working in an interoperable environment is going to read a drawing and go, yeah, that's close enough to 20 feet.
Yeah.
So the detailer probably doesn't want his model. But from
Yeah.
the engineering standpoint, that's very practical. I'm being a
Yeah.
little conservative, saying it's a little longer and
Yeah.
it'll work. So you do have to have that sort of coordination, which is why I'm a big proponent of integrated and interoperable workflows to say,
Mhm.
let's have one source of truth.
Mhm.
That's where that liability should rest. And if everything
Yes.
derives from there, it should all match. Because Mr. Structural Engineer, I get it. It's a lot faster to type 20 feet than 18 feet 9 3/4 inches.
Yep.
But if you got the model from the design department, you didn't have to type anything.
Yep. Absolutely. And so if we tie that back to kind of the digital twin thought and topic, right? The digital twin that the owner wants isn't going to be the designed thing. They want the
As built.
right?
Yes.
The design isn't the valuable part there. It's what is actually built in the field because that's going to be the most accurate when they go to do their maintenance or figure out what's wrong or when they've got to remodel, add on, expand, whatever. As built is what they want as the digital twin.
And if you want to talk about advances in technology, our sister company Leica just released a new tool where you can take a laser scan of a facility and compare it to the 3D model.
Okay.
And actually see, where things overlap, well, that's good because that means that thing is there. But more importantly, you can see where things are in the laser scan that are not in the model to go, well, what's missing out of that model? You know, if this is truly as built, the two should match up perfectly.
Right.
And that's something that we've seen a big push here in technology and around laser scans for verification of as built, as well as, you know, being set up and actually monitoring the progress of construction. So, you know, while a project's going on, you know, hey, if there's a laser scan seeing that, you know, the first 4 frames were put up, nobody questions that, right? Here it is. Here's the live data, you know, streamed over your computer. You can see there are 4 frames put up. That steel erector can go ahead and invoice for 4 frames and not 3 because there's actually 4. He also can't do it for 5. So
yeah. Well, I suppose it creates a little bit of accountability amongst everybody, also, right? Did everybody actually do what they said they did? Yeah, very good. Well, I don't know. We've covered pretty good range of topics here. Kind of talked about the whole workflow all the way through. My whiskey's getting a little low. I'm not sure I need to drink a whole lot more here today. So, I appreciate you coming on here, Geoff. I appreciate the conversation and everything we got going here. The relationship SDS2 has with Hexagon, that's been great. Hope we continue to develop that relationship and yeah, just thank you for everything. Appreciate it. So.
Oh, well, thanks for having me on. I've enjoyed conversations with you over whiskey. What, this is time number 2 or 3?
Well, I think NASCC, we probably stayed up a little bit too late, probably stayed in the bar a little bit too long, but we don't need to tell anybody the details of all of that.
Exactly.
Yeah. We'll leave it at that. So
wonderful. Yeah. Well, thanks so much for inviting me. It's been a fun conversation as always.
Okay. Very good. Thank you, Geoff. And we'll see everybody next time on the next episode of Steel and Whiskey.